Okay, so this is my number 4. Find f prime of x if f of x is equal to e raised to the 3x. So basically what you need to do is chain rule. So f prime of x, you multiply by the derivative of whatever it's being raised to, which in this case is just 3. So you have 3, and then you bring down the stuff, leave that alone. So then your derivative is equal to 3e raised to the 3x. And that's your final answer. Okay, so my question number 5 is, find the inverse function of f at 10 for the function f of x is equal to x cubed plus 5. So first what you got to do is you're trying to find the inverse at 10. So you set your 10 equal to your equation to find the 10 is equal to x cubed plus 5. Okay, so you need to find your x with the inverse. So what you do is 10 subtract 5 from both sides, so 10 minus 5 is 5 is equal to x cubed, and then you take the cube root, x is equal to cube root of 5. Okay, so now that you have your x, okay, you're going to use this to find the inverse of this equation. So the inverse of this equation is 1 of the x cubed plus 5 is 1 over f prime of your x, which is 3 cube root of 5. Okay, and that is how you will find your inverse at 10. Okay, so now that you have this, you figure out what the inverse of the derivative. Find the derivative of your equation, which is 3x squared. Okay, so you use that, plug in your x, so 1 over 3 times cube root of 5 squared. Now, you can simplify this. Because this is 1 over 3 times the cube root, this can be rewritten as a cube root of 5 squared. So then you get 3 times the cube root of 25. And yeah, that's your final answer. That's your inverse at 10. Okay, so this is my number 7. Sorry, I should have written that down. Okay, so the equation is a particle travels along a line. Its velocity in meters per second is given by v of t is equal to t cubed minus t. So there's 3 parts to this equation. This is the first part, part A. What you have to do is find the displacement from t is equal to 0 to t is equal to 2. So from 0 to 2. What you need to do for this equation is make an integral. Your bounds are going to be 0 to 2, and then your equation is t cubed minus t. So you integrate this equation, and from here you get t to the 4th over 4. You integrate t to the 4 minus 4 all over t squared over 2, and then your bounds are still 2 and 0. Okay, so from here you just plug it in, subtract your upper bound from your lower bound, so you get 2 to the 4th all over 4 minus 2 squared all over 2. And then your 0, that was just plugging in the 2, now you need to plug in your 0. Okay, so if you plug in your 0, you're going to get 0 to the 4th and 0 squared, which is just going to be 0, so minus 0. Now 2 to the 4th over 4, this reduces to 16 over 4, minus 4 over 2, which is 4 minus 2, which is just equal to 2. So yeah, that's the displacement from 0 to 2. Part B. We need to find the distance traveled by the particle from t is equal to 0 to t is equal to 2. Okay, so we are going to use the position formula for this equation. I mean, not the position, the velocity formula, which is again equal to t cubed minus t. Now you need to set this equal to 0 so you can figure out where the time is, like where it's not moving, so where it's equal to 0. Yeah. Okay, so you can pull out a t to make this easier. So t squared minus 1. So t is equal to 0, and then t squared is equal to 1. So t is equal to plus or minus square root both sides. T is equal to plus or minus 1. Okay, so the t is equal to 1 is irrelevant because, I mean, t is equal to 0 is irrelevant because it's gonna be 0 at 0, obviously. Okay, what we need to do is figure out is this t is equal to plus or minus 1. You make a timeline to figure out like where it's moving. Yeah, okay, you need to find the total distance from like where it's moving, regardless of whether or not it's going like up or down. So you need to make two integrals. One is going to be from 0 to 1, t cubed minus t, and then you need to add that to your second integral, which is going to be from 1 to 2, and then, oh, this is a cubed, and then, yeah, this is going to be, again, t cubed minus t. So you can figure out, like, the distance, and you're going to have to find the absolute value of the distance from 0 to 1, because you just need to find the distance, and it's going to turn out negative, but you can't have negative distance. Okay, so yeah, from here we got to integrate. T to the 4th over 4 minus t squared over 2, bounds 0 to 1, and then plus, again, t to the 4th over 4 minus t squared over 2, bounds 1 to 2. Okay, so you need to subtract this, subtract top from bottom. So you're going to get 1 to the 4th over 4 minus 1 squared over 2 minus, okay, so your lower bound is 0. Obviously, it's just going to be 0. So minus 0. And then this is being added to this second integral from 1 to 2. Okay. So t2 to the 4th over 4 minus 2 squared over 2 minus, now you got to plug in this one. So 1 to the 4th over 4 minus 1 squared over 2. Alright, okay, so you have 1/4 minus 1/2 plus 2 to the 4th is what, 32? 16? Yeah, it's 16. Okay, plus 16 over 4 minus 4 over 2 minus, okay, so this needs to be in parentheses because it's going to be 1/4 minus 1/2. This is all being added. Okay, 1/4 minus 1/2, negative 1/4. See how you have this negative distance? You don't want to have a negative distance. You're trying to calculate the whole distance that the particle is traveling. Okay, yeah. Plus, and then you have 4 minus 2 minus a negative 1/2. I mean, negative 1/4. Yes. 1/4 minus 1/2, negative 1/4. Okay, so now you have 1/4 plus 4 minus 2 is 6 plus 1/4. That is going to be 9/4. Okay, so you have 10/4 now. 1/4 plus 9/4 is equal to 10 over 4. If you want to, not reduce it, but make it into a mixed fraction, it'll be 2 and 1/2. And this is the total distance traveled from 0 to 2. Yeah. Part C of this equation, of this problem, number 7, is the speed of the particle increasing or decreasing at t is equal to 1.5? And then justify your answer. Okay, so for this one, what we need to do is find the velocity. The velocity and the acceleration as well, because we need to figure out if they're both increasing, or if one's increasing, decreasing, or if they're both decreasing. So yeah, you plug in 1.5 into this equation, into the velocity equation, which is equal to 1.5 cubed minus 1.5. Okay, I've already calculated this. It's going to be 15 over 8. Okay, so now you need to find your acceleration. How do you find your acceleration? Well, you need to integrate. So you're going to integrate using the velocity equation, which is t cubed. Not integrate, antiderive. You need to antiderive your velocity to get your acceleration. So, yeah, you get 3 t squared minus, you're not taking the antiderivative. You're just taking the regular derivative, I'm sorry. Yeah, you just take the derivative because if you were trying to find the acceleration, then you would take the antiderivative. If you're trying to find the velocity, you would take the antiderivative. But they give you the velocity, so yeah, to get the acceleration, it's just taking the derivative, which is 3t squared minus 1. Okay, acceleration of, you also need to plug in your 1.5 into the acceleration so you can figure out where it's increasing, decreasing. So acceleration at 1.5 is equal to 3 times 1.5 squared minus 1. Okay, this is going to equal 23 over 4. Once you square this, because this is 3 over 2 squared times 3 minus 1. 23 over 4. Okay, these are both positive numbers, which is what we were trying to figure out, which means that they are both increasing. And if they're both they're both positive, so they're increasing from at 1.5. Increasing, yay. Increasing due to positive velocity / acceleration. Yep.